All right, so now that you are experts at solving proportions with lots of different methods, cross products, maybe equivalent fractions, we need to look at why proportions are useful for us in real life and what situations we could have proportions that come from where there's a variable where we have to solve it. So we're going to look at situations and write our own proportions and then be able to solve them. So here's some hints that you can always come back to if you get stuck when you're writing your own proportions from these real-life situations. You're going to ask yourself, does this situation describe what we call a proportional relationship? Should we be making a proportion in the first place? So what does a proportion have? A proportion uses two equal, what was the definition of a proportion? Two equal ratios. And we'll talk in our next unit about making sure that things are going to be proportional relationships before we start. For this worksheet, all of these, they are proportional relationships. Every single one of them, you'll be able to write a proportion. So we just need to make sure we remember a proportion is two equal ratios. The next step is going to be to create a blank proportion to kind of fill in some blanks. So if it's two equal ratios, it's going to look something like this, where you've got space for four different numbers, a ratio, and making them equal. So making that blank proportion. And when you're deciding where to fill in the numbers, we've got to put them somewhere, we're going to look for two numbers that already have some given relationship, that are already in a ratio. We're going to use this as our first ratio. So if they're comparing in the statement, there are 4 apples for every 3 oranges, that is already a ratio. That's what we would start with. We're going to make sure when we're filling in the rest that the top units on the left match the top units on the right. Our units here and here have to equal each other. If we've got apples up here, that has to equal apples over here. Oranges has to equal oranges down here. So we're going to be careful when we match up our units, and you'll see that. All right, there is a different way to do it also. You could also, if you get comfortable with this method, have the units all in the left-hand ratio the same and the units in the right-hand ratio the same. We'll see a couple of examples where that might be good. And then the last thing is, when you only have 3 given numbers in a problem, we're only going to have 3 numbers. The 4th number is most likely going to be what we don't know, which is a variable. So I'm going to come back. This doesn't make as much sense until you've tried it, and we'll point these things out as we're going. All right, we're going to solve each problem down here by writing a proportion. And for here, there's some practice problems. For 1 through 4, you're going to use cross products to solve it. Once you write a proportion, let's practice our cross products so that we know that we can master that method. For the rest of them, after number 4, you could use cross products if you want to, or if there's a faster method, equivalent fractions, or something you want to do, you can do that for the rest. So I'm just going to do a couple of examples with you and let you practice the rest on your own. Let's just do number 1 right here together, because it is here. We're going to write a proportion for this and then solve it. This says a scale model of a whale is being built. The scale of the model is 2 inches to 3 feet. Right there, I recognize a ratio. I'm just going to stop and circle that so I can come back to it. The actual length of the whale is 65 feet. What will be the length of the model? So using my reading strategies here, is there any vocabulary I need to clarify? Do you know what a scale model is? It would be something like at a museum where it's much smaller or much bigger than the real thing. In this one, if it's a scale model of a whale, do you think it's being built smaller or bigger than a whale, like to put in a museum? Probably smaller. A whale's pretty big. All right. So the scale model, let's see, we know our vocabulary. What is the purpose? What's the question? What are we trying to find out? What is the length of the model? All right, so that's our variable. That's going to be our x, the length of the model. We're going to use now our steps. We know we're going to write a proportion for number 1. Number 2, let's create a blank proportion. So down here, I'm going to create my blank proportion. And I know there's 4 spaces I can fill in. Number 3 says, number 2 still says, look for 2 numbers that already have a given relationship and use this as our first ratio. So do we have a ratio in the problem? 2 inches to 3 feet. Yes, that is a ratio. I'm going to use that as my first fraction ratio. 2 inches to 3 feet. And notice for this, I am using units, because when we're writing the proportion, we need to be aware of matching up our units. So include them in your proportion. If number 3 says make sure the units match up. If inches are on the top here, inches have to be on the top here. If feet's on the bottom, feet has to be on the bottom there. So you can write in your units. That's going to help us place our next piece of information, because we know the actual length of the whale is 65 feet. So where does the 65 go, the top or the bottom? It has to go on the bottom, because that's where we already wrote our words feet. If feet is on the bottom here, feet has to be on the bottom there. And then our only thing left must be our x, but let's make sure it makes sense. What will be the length of the model? Well, does it make sense that the length of the model would probably be in inches if it's getting smaller than the actual whale? Okay, there's our proportion. That's the only new part here, is being able to set this up on our own. And now once we have this, we should be able to solve it. And remember, for 1 through 4, we're just going to do cross products just to practice that. So let's write out this times this equals this times this and solve for the x. This times this equals this times this. 2, now for this part, you don't have to rewrite the units again. 2 times 65 equals 3 times x. We can simplify now. 2 times 65, we should be able to do that. 130 equals 3x. To get the x by itself, I divide both sides by 3. And I get this, 43.33333. So let's say x equals 43, and let's be careful here. Either I need to say 3 repeating, because it does go on forever, or what fraction would that be? 43 and 1/3. So we could do that as well. And what are our units? We do need units for our final answer. What would be the length of the model? 43.3, x was in inches. All right, and does that make sense? It's getting bigger here, about 20 times as big. 20 times as big, okay. So that's how we set up a proportion, and then solving it should be not a big deal. We've solved the proportions already. Let's take a look at another one on here. It's a little bit tricky maybe. How about 3? Let's skip down to number 3. This is only tricky because all the units are going to be the same. So the smallest frog known is only 1/2 an inch long. Gosh, that's tiny. A local science museum is planning to build a model of the frog, so this is another scale model. The scale used will be 3 inches to 1/4 of an inch. So do you think this model is going to be bigger or smaller than the actual frog? That's tiny already, right? So hopefully the model will be bigger so we can see the different parts of the frog. We want to know how long the model will be. So our first step here is, we know it's a proportion, so let's write a blank proportion. Where are we going to fill in our numbers? Do we have a ratio given to us in the problem that already, 2 numbers that have a relationship already? Yep, there's a ratio. Let's use that as our first fraction ratio here. 3 inches for every 1/4 of an inch. So I can write 1/4, or since I know I'm going to have to be doing some calculations, I kind of want to just change that to a decimal right now. Can I put 0.25 inches? Because I know that's 1/4. Now this is different than the last one because these are all inches. Inches on the top, inches on the bottom. That's going to be harder for us to decide what to put in, where to put in our last number. We know that the smallest frog known is 1/2 an inch. So that 1/2 inch has to go in one of those, but we've got to figure out which one. So for this, we've got to look at, well, this 3 inches for every 0.25 inches. Which one is the real frog? We said the real frog's probably the small one, right? This is the real frog, and this is the model. They're going to make that model 3 inches for every 1/4 inch of the frog. So what we want to make sure is we keep all the model measurements on top and the actual frog measurements on the bottom. So this one, we know it's 1/2 inch long. Is that the frog or the model? That's the frog. So this 1/2 inch needs to go on the bottom with the frog. And instead of 1/2, can I put 0.5? Because I know that's 1/2. And then it asks us, how long will the model be? There's our x, our model number. So we've set up a proportion. Can we solve it? This is still 1 through 4, so we still want to use cross products, even though there are other ways. I could see from here to here, we're multiplying by 2, right? From here to here, we should be multiplying by 2. So I'm hoping to get 6 to get this. Let's make sure it works with cross products. 3 times 0.5 equals 0.25x times x. 3 times 0.5, what's half of 3? 1.5. I'm going to divide both sides by 0.25. So I get that x equals 1.5 divided by 0.25 gives me 6. There we go. Now 6 what? 6, so these are all inches, so 6 inches. And we already looked at it and expected that, so that makes sense for us. All right, so there's a couple others on here that you'll come back to and look at. Let's look at the next page, and let's just pick one of these to do here. Let's see. Let's take a look at how about number 7 right here? Ooh, my marker is bleeding through my paper here. Let's look at number 7. The shipping charge on a 30-pound package is $6. How much would the shipping cost on a 50-pound package be? Oh, there we go. How much would the shipping cost be? So let's make a blank proportion. Do we have a relationship already? Do we have a ratio given? We know 30-pound package is $6, so it's $6 for every 30 pounds. That right there is a ratio. Which one should we put on the top or bottom? Does it matter if I put 30 on the top, 6 on the top? The answer right here is it doesn't matter for your first ratio. We could say 30 pounds for every cost us $6. As long as we keep pounds on the top over here and dollars on the bottom over here, that's fine. We could also have put $6 on the top and pounds on the bottom, but then over here we'd have to put dollars on the top and pounds on the bottom. As long as you keep your units equal to each other, you're fine. What else do we know? We know we want to find a 50-pound package, and we want to find how much that's going to be. It's going to be a same relationship. If $6 for 30 pounds, how many dollars for 50 pounds? And we're going to write it out like this. Now this one, we're past number 4, so we could use a different method other than cross products. If it was easy for you to say, how do I get from 30 to 50? What would I multiply by? If you can do it that way, great. I'm just going to do cross products because for me, I think it's going to be just as fast. And I'm going to say 30 times x equals 50 times 6. This times this equals this times this. 6 times 50, 5 times 6 is 30, so 300 equals 30x. I don't think we need a calculator for this one at all. Divide both sides by 30, and 300 divided by 30 should give us 10. 10 what? Yep, dollars. Dollar sign there. So $10 for shipping. Okay, at least it's more than 6. Not quite double. 30 is not quite, or 50 is not quite double 30. So I'll buy that. I'll go with that one. So that's the strategy for setting up your proportion. If you get stuck when you're doing these, come back and go through the steps. Look and see. Make sure you're looking for a ratio, keeping the units equal to each other, and hopefully your blank space is going to be your variable. All right, we're going to let you try this rest of this on your own and see what you can come up with. Don't forget units in all of your answers.